Some of this stuff you've already learned. Some of it you have not. You're going to be taking pictures today, and I'm going to go as quickly as I can because we don't have a lot of time today. Yeah, I got about 20 minutes, I think. We should be close. Okay, the beginning part you know. Okay, you've learned about limits. Okay. Go ahead and just take a picture of this screen. Okay, this means the limit as x approaches a of the function f of x equals some number L. Okay, this x does not necessarily have to equal a. Okay, in fact, a doesn't even have to be in the domain. It can approach some number that's not in the domain. And when things like that happen, that would mean, for example, let's say x approached 0, but if you plug 0 into the function, it would make it undefined. Okay? That would be an example of how a number could not be in the domain. We would have to exclude it because it would make it undefined. Okay? And over here we have 3 examples. Clearly, here's x. This is where x equals a. And at a, the function is approaching L. From the left, it approaches L. From the right, it approaches L. And f of a is L. Okay. Now, over here, f of a is not L. F of a is some other value. Don't know what it is, but it's not L. But if you notice, this function from the left approaches L. Doesn't ever actually get to L. And from the right, it approaches L. Again, doesn't ever actually get to L. That's why there's a hole there. Right. But in all 3 of these cases, the limit is L. Now, okay, so f of a does not equal L. It's something else. But the limit is still L. Okay. Now here, there's no f of a anywhere. F of a does not exist. This is where f of a would be, but there is no f of a. But again, from the left, it approaches L. From the right, it approaches L. Okay, and again, f of a still does not equal L. And so what's important about limits is this idea as we can get closer and closer and closer to a specific x value, we can see that the function oftentimes still approaches a certain value as well. And that is what the limit really is. Now, and take a picture of this page. Now, when I made this, my numbers were all off, so I'm going to remake it right now. Okay. So the thing that's going on here, x is approaching 2. If x equaled 2, what would be true of this function? It would be undefined because we would be dividing by 0. So this would be undefined. So 2 is not in the domain. We have to exclude 2. It's an excluded value. Now, what we can see here is that we are approaching from the left. Okay, 1.9, then we get a little closer, then we get a little closer, not quite to 2. Okay, so this would be approaching 2 from the left. This would be approaching 2 from the right. I get a little closer, I get a little closer. Okay, so we're approaching from both sides of 2. Now, I understand you guys have done table of values like this before, yes? Okay, so let's fill it out. Okay, this part we already said was undefined. Okay, and so this is going to give me 4,000. This is going to give me 400, and this is going to get, and this one is going to give me 40 when I plug those values in. This one is going to give me negative 4,000. This one's going to give me negative 400, and this one is going to give me negative 40. Okay. So here's what we can conclude, right? As we get closer to 2 from the left versus as we get closer to 2 from the right, are they converging towards the same number? No. If I went 1.9999, what's the next number going to be? Negative 40,000. But if I approach from the right and go 2.0001, it would be 40,000. And if I kept adding zeros, this number gets smaller and smaller and smaller. This number gets bigger and bigger and bigger. But they're going in opposite directions, right? So what would we say about this limit? What's the limit? What is this limit? Is it going toward the same number? No. Then what we say is that this limit does not exist. Okay, this means does not exist. We would never say the limit is undefined. That is not the case. Okay? The function at 2 is undefined. The limit itself does not exist because the left-hand side goes one place, the right-hand side goes to another place. Okay? And this is what we're getting to, and this is the part that I think is new for you, is that there's such a thing as a left-hand limit and a right-hand limit. And in order for the limit of a function to exist, the left-hand limit and the right-hand limit have to equal each other. All right, and that's what's being said over here. And so here's what the notation for a hand limit looks like. X approaches A, and this negative sign is like a power. It's a superscript. What this means is the limit of f of x as x approaches A from the left. Now, we also can approach from the right. And we approach from the right, the notation changes a little bit. It's all the same, except instead of from the negative side, we approach from the positive side, which is the right. Okay? Like I said, I don't think you guys covered this in pre-calc. Okay. Got it. Well, this is going to be a critical thing that we talk about in here. Okay. We need to have the ability to talk about a limit from the left and a limit from the right. Why is that important? Just like on the last example, it's important because if the left-hand limit and the right-hand limit are not the same, then the function doesn't have a limit. And that's what this says. Whether you want to take a picture of that or screenshot it from page 88, I don't care. But what this is really saying is the limit of a function as x approaches A exists and equals L if and only if, meaning both of these must true. The left-hand limit must equal L and the right-hand limit must equal L. Here's the example that we just talked about for the graph and why it's important. I just sent it. I just sent you guys an email. Ignore it. That was for the other class. Here's what's important to notice. As I approach 2, so here's 2 right here, the line x equals 2. Okay, as I approach 2 from the left, we can see that the graph is going toward what? Negative infinity. As I approach 2 from the right, it's going up forever, so it's approaching positive infinity. So since the left-hand limit goes one place, the right-hand limit goes the other place, that's why this limit does not exist. Okay? Now, one of the things you're going to have to do is determine what the limit is from a graph. All right? And so I went ahead and had this problem, created this problem. Limit approaches as x approaches 0 of sine of x over x. Is 0 in the domain? Why not?
Undefined.
Because it would make it undefined. But if we look at the graph, and if it approaches the same y value from the left that it does from the right, then this will have a limit, even though the function is undefined at when x equals 0. So I'm going to put some pictures up here, and you can take a picture of this.
Can you just repeat what you said?
Sure. We're going to approach 0 from the left on the graph, and then we're going to approach 0 from the right on the graph. Okay, and these are the pictures that I've provided for you. So this is the original graph here, where there's a hole. There's a hole because x cannot equal 0. However, if we look down here as I approach 0 from the left, okay, I get this. And see, this is sort of to prove that I'm on the left side of 0. If I approach 0 from the right, again, I can see that I'm on the right side of 0. We seem to be approaching the same number. And you can see that visually, right? You can tell that the graph from the right and the graph from the left are approaching the same y value, which is 1. So the limit exists because the graph approaches 1 from the left at 0, and the graph approaches 1 from the right at 0. That's why the limit exists, even though the function is undefined when x equals 0. And so it's very important to understand when we're talking about a limit of the function, the left-hand limit and the right-hand limit have to approach the same number in order for there to be a limit of the overall function. Does that make sense? Huh?
I already know it's approaching 1.
All I heard was how do you know, and then I didn't hear anything else.
No, how do you know it's 1?
Well, what is the y? Look at these y values.
Oh.
Okay. Yeah, because the scale on this is wonky, so this is 1. But yeah, you've got the y values at the bottom that kind of show you where it's going. And if I could zoom in some more, it would get closer and closer and closer, and it would again it would approach 1. Okay. All right, now, see if we can get through a couple of these graphs. Go ahead and take a picture of this screen. I did. That was pretty funny. It's just a split second too late. Okay, so we've got this graph. Okay, so the first one says this is the function f of x. Okay, x is approaching 0. All right, so here's where x is 0. Where is the function going from the left and from the right? From the left, it's going to 3. From the right, it's going to 3. So the limit, that one's pretty easy, right? That one's just 3. The y value is going to 3 at 0 from the left and from the right. Now, we see a split here at x equals 3, which is why you see this stuff going on. So as I approach 3 from the left, this way, where's it going? It's going to 4. As I approach 3 from the right, where is it going? 2. Do they go to the same place, the left-hand limit and the right-hand limit? No. They do not. So then the limit as x approaches 3 of the function does not exist because they don't go to the same place. The left-hand limit and the right-hand limit are different. F of 3 does exist, though. What is f of 3? 3. That's just saying what's the y value when x equals 3. So that's this point right here. Okay. Questions on that? All right.
For number 2, how should
All right. I'm going to jump to the last one. There's another example here. It's the same idea, okay? But there's more of them. If you wanted to go and do them, you can. But one of the things I will tell you about this graph is assume that it never touches here, assume that it never touches there, okay? Assume that we've got an asymptote there, and that will help you get those. But I really want to get to this question, okay? Because you're going to have to go the other way now. They're going to give you a bunch of conditions. They call them characteristics, okay? And you have to sketch a graph that meets all of these characteristics. Now, understand there could be definitely multiple pieces. And you have to kind of decide where you want to start. Like for me, when I look at this one jumps out at me here. There's a point at 2, 1. Might as well graph a point 2, 1. Then you've got to draw some sketches that reflect the rest of this stuff, okay? F of 0 is undefined, meaning we're never going to be on the y-axis. So give that a shot. So let's talk about some of the things that we can do right away. Again, there's a point at 2, 1. You should plot it. You should not ever touch the x-axis because of this. Okay, so I've got 2 things. Now, here what I have is, notice that from the left, as x approaches 0, y is 1. But from the right, it's -1. So I'm going to go one way from the left here. I'm going to go another way from the right here. And then the same thing is true here. As I approach 2 from the left, it's going to be 0. So it's going to get close to 0. But as I approach 2 from the right, it's going to be close to 1. So I've put a couple graphs up here that could be. There's lots of options. Okay? In both cases, I have that point 2, 1. Okay, I approach, notice I have open circles on the y-axis because we can't touch there. If I approach 1, or approach 0 from the left, it equals 1. So I'm approaching 0, it's 1. Approaching 0, it's 1. Okay, as I approach 2 from the right, it's 1. And then you have the in-between, okay? So there's lots of different options for this particular one. Those are the ones that I drew.